Okay, welcome to lesson 53. So this is the last one. So yay or whatnot. So this is for when we're looking at categorical variables or discrete variables. Specifically, these will look like counts, proportions, or percents. So we're going to have the P chart and the C chart. So the P chart monitors the proportion of successes for a particular process. So here we have a number of subgroups. So we have 30 subgroups. Within those 30 subgroups, so you take 200 like trials or subsamples in there, and you count how many successes you have. This should make you think of the binomial process. Absolutely. In fact, it should look really, really like it. So what you do here is you look at the proportion of successes in all of your subsamples. You average them. So just our individual p-hats, that's the number of successes. And I say successes loosely. It could be the number of defective parts or non-conforming parts over the sample size taken. P bar is if I went and I took all of those sample proportions and averaged them. So then, it's going to be P bar plus or minus 3 times square root of P bar times 1 minus P bar over n and the square root. So it does have, and this should look really similar to the binomial as well, you need to have expected at least 10 successes and failures in each subsample for this to be roughly normally distributed, basically to make it okay for us to use that plus or minus 3 times bit. So note, because we're looking at proportions cannot be negative. So if your lower control limit has a negative value, you need to cut it off at 0. You need to use 0 as your lower control limit if the one you calculate is negative. Oops. Okay, so these data here, they represent, if you took a peek at the P chart on the previous page, we were looking at the number of non-conforming. So weird, but this is what we called a success. It's more of like, hey, is it present? ROM computer chips out of a sample of 200 for 30 consecutive days. So day 1, we take a random sample of 200 ROM computer chips, count how many of them are non-conforming, and then do this for 30 days. One of the days ended up getting removed, and we want to so remove the 5th day and recalculate the lower and upper control limits here. So here, so it's saying, yeah, that day it was exceptionally high. So n is equal to 200, and p bar is equal to 0.0914. So my lower control limit, it's going to be P bar minus 3 times P bar 1 minus P bar over n. So I'm going to have 0.0914 minus 3 times 0.0914 times 9082, I believe. Every once in a while I do this quick mental math and it could be off, so just a caution. Definitely double check that. Yeah, for starters that should be a 6. So then I end up getting, round a little bit, 0.0303. And so these are proportions, there are no units. So this is my lower control limit. Note, it is positive, so I don't need to cut it off at 0. It's okay. And then upper control limit, so P bar plus that amount. So square root. So it's going to be that 0.0914 plus 3 times. I might just not try to do the mental math here. 0.0914 over 200 is the sample size for each subsample. I end up getting something like 0.1525 is my upper control limit. So keep in mind, the lower control limit cannot be, so lower control limit has to be at least 0, upper control limit has to be no bigger than 1. So keep that in mind. If this went above 1, I would cut it off at 1. So before, the P chart should be like a throwback to the binomial. The C chart looks at the count or number of successes for a particular process over space or time. Specifically, the space or time increment are the same for each subsample. This should make us think of Poisson distribution. So our lower and upper control limits, so remember Poisson, so x bar plus or minus 3 times x bar, because the variance of Poisson was x bar. So things to know, so x bar is just if I took the average of the counts across all the subsamples, and that's pretty much it. It's probably the most straightforward of these control charts limits to calculate. So this is an example of one. Note that these are counts now, and the counts have to go from 0 on, right? It can go on forever and ever. They're integers. The averages don't have to be integers though. Okay, so once again, if our lower control limit is negative, replace the value with 0, because you can't have negative counts. Okay, so the example we're going to work with, making a C chart, we're looking at a car production line. So they go ahead, they pull every 200th car off the production line and count the number of defects it has. What a definition of a defect is? Not sure. So they do this until they have 20 cars, and then so we have 20 counts of how many defects each car has. So if I want to find the average of these, real straightforward, I'm going to add all of these up and then divide by 20 because there are 20 of them. So that's what this is, x bar. I have 20 subgroups here. So that's going to be that like 8 plus 5 plus ... all the way through 14 over, there are 20 of them. And I end up getting 6.3. Totally fine that this is a decimal. This is an average. Counts, average counts can be decimals. That's fine. So then from there, I pretty much have calculated everything I need to put this together. So my lower control limit is going to be x bar minus 3 times the square root of x bar. It's going to be 6.3, I'm going to put the equal sign here, minus 3 times the square root of 6.3. So I'm going to get negative 1.23. Remember, these are counts. You can't have negative counts, so use lower control limit equal to 0. You can even see that's what they did here. They cut it off at 0. Our upper control limit, x bar plus 3 times the square root of x bar. I'm going to get, it's going to be the same numbers except I'm going to add plus 3 times the square root of 6.3. I'm going to get 13.83. So looking here, yes, they got something similar. So slightly different rounding. That's why this sometimes ends up being a little bit off. This is an excellent way to check your answer. It does not work in and of itself. So if we ask you to calculate it, we will want to see this. There is no upper limit on the count you can have. I mean, I have no idea how many, it could just go on and on how many defects it has. The minimum is 0, but it can go on and on. So these are absolutely fine if they're not whole numbers. Please do not round them to integers. That will not go well. So I believe, yes, now it is your turn. So give that a try. It was an interesting experience, this remote term, and I hope to hear from y'all. I hope to hear your questions that you have on this, and I'll get this out soon, this afternoon. Okay.